Flux is the hottest image generation model lately. It was created by the former SD team, who left StabilityAI to start their own venture, and developed this 12B parameter model, which is hailed as the true SD3. Since its release, I've been researching and experimenting with it tirelessly, producing enough images to wrap around the Earth 3 times. With some humility, or perhaps very little, I can say that there are, very few, people who know Flux better than I do. Today, I will compile this information to provide you with a comprehensive review and tutorial. This video can be regarded as an encyclopedia for getting started with Flux. It's rich in content and full of valuable insights, but it's quite lengthy. You might want to give it a thumbs up, save it, and then watch it at your own pace. I'll begin by introducing the Black Forest team that released the Flux model and its connection to Stable Diffusion. Then, I'll introduce the model. Why are there so many different models? Which one should we choose to download? How much system resources do different models require? Next, I'll cover the preparation work, including updating ComfyUI and some plugins. Then comes the practical part. From the perspective of text-to-image generation, I'll explain how to use Flux and ComfyUI to generate the first image, the significance of each node and its parameters, the different resolutions supported by Flux, test Flux's prompt understanding ability, and perform face correction, face swapping, and image upscaling. For image-to-image generation, I'll first demonstrate how to achieve anime style transfer, followed by local redrawing using InPainting and Detailer. At the end of the video, I'll introduce the progress made by the open-source community in supporting Flux, including LoRa, ControlNet, and more. Alright, let's officially begin. I wonder if you've ever heard of the ship of Theseus. It's a philosophical problem that asks, if the wooden parts of a ship called Theseus are gradually replaced until none of the original wood remains, is the ship still the same ship? And if you rebuild a new ship using all the old wood from the original ship, is this new ship the original Theseus? StabilityAI and Black Forest Labs are like these two ships. Let's review the related timeline. On December 20, 2021, Robin Rombach, now a core member of Black Forest Labs, and 4 other scientists co-authored a paper titled High-Resolution Image Synthesis with Latent Diffusion Models. This paper formed the core theoretical foundation of Stable Diffusion. Notably, 4 of these 5 authors are now working at Black Forest Labs. On August 10, 2022, StabilityAI announced the official release of Stable Diffusion. In the announcement, Patrick Esser and Robin Rombach were explicitly mentioned as the project leaders, and they are both now members of Black Forest Labs. In papers published on July 4, 2023, and November 25, 2023, which elaborated on the core theories of SDXL and SVD, Robin Rombach appeared in the list of authors. On March 18 of this year, just weeks before Robin Rombach left StabilityAI, he published his last paper there, detailing how to achieve SD3 Turbo, which could generate images in just 4 steps. Isn't that the Flux Schnell we have now? On August 1, Black Forest Labs, formed around Robin Rombach, announced its establishment and released the Flux.1 model. So, is Flux more legitimate than SD3 Medium? What do you think? The Flux models released this time come in 3 versions, Pro, Dev, and Schnell. The Pro version is the top-tier model with powerful performance, capable of accurately generating high-quality and highly detailed images based on user input prompts. It supports various styles and scene complexities, but like Midjourney, the model is not open source and can only be accessed through APIs and specific cloud providers. The Dev and Schnell versions of the models are open source and can be used locally in ComfyUI. Among them, the Dev version has better performance but has a non-commercial license, similar to SD3 Medium. The Schnell version, on the other hand, uses an Apache 2.0 license, making it available for commercial use. However, it's a fast model similar to Turbo, focused on generation speed, so its performance is slightly inferior to the Dev version. However, according to the benchmark charts provided by Black Forest, even the Schnell version scores higher than Midjourney v6.0. Black Forest has not yet released a detailed technical report only mentioning that the model uses a hybrid architecture combining multimodal and parallel diffusion transformer blocks, with a parameter scale of 12 billion, and incorporates key technologies such as flow matching, rotary positional embeddings, and parallel attention layers. We won't delve into the technical details here. But once Flux's technical report is released, we can compare it with SD3 and or Flow. Besides the official versions released by Black Forest, there are several versions of the Flux Dev and Schnell models available in the open-source community. The ComfyUI team ComfyOrg and the famous plugin author Kijai, who is the K guy, have also released their own versions. So, what are the differences between these versions, and which one should we choose? Let's answer these questions below. Let's take the Black Forest Dev version as an example. The 23.8G file in the list is the dev model, while the Schnell model is in another repository, also sized at 23.8G. Both models use the BF16 data format. However, downloading just this file is not enough. To use it locally, you also need the corresponding clip and VAE. Clip is responsible for converting text prompts into a format the model can understand. You can download it from the ComfyUI provided repository, which includes the clip_L and T5XXL files in the list. The two T5 files have different data formats. FP16 requires more resources than FP8, so you can choose one based on your needs. VAE, on the other hand, is responsible for decoding the final image from the latent space to the pixel space. And you need to download the 335M file from the Flux repository. In other words, if we choose to use the official version of the model, the Kijai version is the same. You'll need a total of 4 files: the model file, placed in the init directory, clip, placed in the clip directory, and VAE, placed in the V directory. The official version of the model is in the BF16 format, with a size exceeding 20G, so the threshold for using it is relatively high. Kijai and ComfyOrg have used code to split the data within the model, generating FP8 versions. These compressed models may have slightly lower image quality but significantly reduce resource requirements and increase image generation speed. Among the two FP8 versions, the ComfyOrg version is a safetensor file that integrates 3 components into one, equivalent to the Kijai version plus clip and VAE. If you download the ComfyOrg version of the model, you only need 2 files, which should be placed in the checkpoints directory. You can create a new folder. While the Kijai version of the model is completely consistent with the official one, placed in the init directory, and also requires separate clip and VAE. In summary, if you have a good graphics card, such as a 4090, it's best to use the official BF16 version for the best results. Otherwise, it's recommended to choose the ComfyOrg or Kijai FP8 lower threshold versions. For those with ample disk space who don't mind downloading clip twice, I recommend the ComfyOrg version for its convenience. The easiest way to use the Flux model is through ComfyUI. If you've installed ComfyUI before, you just need a simple upgrade by running update/update_comfyui.bat, or using the upgrade function in ComfyUI Manager. If you don't have it installed locally, you can download the latest weekly version of ComfyUI from the official website. For detailed information, you can refer to my previous videos. Some plugins have also released new versions supporting Flux, such as the Face Detailer plugin ComfyUI Impact Pack, which can be upgraded through ComfyUI Manager. ComfyUI offers multiple versions of workflows for different types of models mentioned above, mainly differing in how they are loaded. I will demonstrate the loading of each different type of model within this workflow later. First, let's load the workflow for the ComfyOrg version of the FP8 format Flux Dev model. Select the corresponding model. Modify the positive prompt to describe a specific girl. Enter a preferred seed, and then fix it. Open the resource monitor and note the current memory and VRAM usage. After clicking Generate Image, check the VRAM usage during the process. It peaked at 13.1 G, and memory usage reached 40 G. After the image generation was completed, the VRAM usage quickly dropped. Looking at the generated image, I personally think the result is excellent. Flux excels in rendering different scenes, especially in the performance of light propagation and depth of field. Before switching to another model file, I first organized the model loading part in the workflow, grouped the load checkpoint node used in the previous version, and modified the title. Then, I routed the model, clip, and VAE separately to a reroute for subsequent operations. Grouped them for easy viewing. Reroute is essentially just for easier wiring, and the current workflow is identical to the previous one. When you run it, you'll find that the image result hasn't changed. Now, let's switch to the Kijai version of the model. This is a net type model, requiring a different node for loading. Add the Load Diffusion model node, select the FP8 format dev model, and set weight_type to FP8_E4M3FN. Be careful not to select the wrong one. Next, add the dual CLIP loader node to load clip, similar to the operation when using SD3 medium, except Flux lacks a clip_G. We select T5XXL_FP8 and clip_L, and set type to Flux. Next, add a load VAE node, selecting the AE model provided by this Flux repository. Then group them together and slightly modify the title. Connect the output of these nodes to the corresponding reroute nodes above. This way, the entire workflow only replaces the model while keeping other parameters unchanged. I added an extra image node to compare the results generated each time and slightly modified the names for marking. Before running, check the Resource Manager, where the current VRAM usage is at 1.3 G. After clicking Run, the VRAM usage peaked at 13.2 G, similar to the ComfyUI's FP8 model. Generally, if you want to use the FP8 version of the Flux model, 16 G VRAM is sufficient, so users of 3090 and 4080 can breathe a sigh of relief. However, it's best to have system memory of more than 24 G, otherwise, it might be a bit challenging. Zoom in to check the raw image result just now. The image is consistent with the result using ComfyUI's FP8 model previously. As we mentioned earlier, the only difference between these two models is the loading method, with similar results when using them. Next, we'll use the last model, the official Black Forest dev model. This model, like the Kijai version, needs to be loaded as a .NET model, but its data format is complete BF16, so the model file size is about twice that of the FP8 version. Copy the three nodes above, group them, and modify the title. Select the Black Forest dev model and change the weight_type to default. In theory, Clip can continue using T5XXL_FP8 with similar effects, but for consistency, I replaced it with the FP16 version. Other parameters remain unchanged. Complete the connections. Similarly, I added an image node and modified the name. Before running, the VRAM usage was 1.4 G. After clicking Run, check the usage again. The VRAM usage hasn't increased for now, but the memory usage quickly rises, soaring to 99%. And I have 64 G of memory. The computer was under heavy pressure. After some memory was released, I returned to check the GPU, sped up the generation process, and found that the VRAM usage peaked at 15.5 G, almost maxed out. Finally, the image was generated, and it felt like the computer breathed a sigh of relief. Checking the result, there's not much difference overall, but the image generated by this model has richer details compared to the previous FP8 version. Considering that I'm not using a 4090 or higher level GPU, the FP8 version of the model is clearly more cost-effective, with less pressure and faster speed, and the images generated aren't much different from the full version. Perhaps, after generating a satisfactory image with the FP8 model, using the full version with the same parameters, or using image-to-image for repainting to optimize details would be a good choice. You might ask, how about the Schnell model? It's known for fast image generation. Does it also require fewer resources? Let's find out next. Like the dev model, the Schnell model also has 3 versions. The full BF16 version provided by Black Forest and the FP8 versions converted by ComfyUI and Kijai. With the same data format, its resource requirements are the same as the dev model, not less. We've seen the 3 different loading methods of the model. Here, I chose the simplest one to load the Schnell model, connecting back to the original load checkpoint. Selecting the Schnell FP8 model. The biggest advantage of this model is that it can generate images in just 1 to 4 steps, so I only changed the iteration steps to 4, kept the other parameters unchanged. Clicked Run, and jumped to the result. Although the image generation was fast, I personally think the result is not as good as the dev model. Increasing the iteration steps can improve the image details. I simply changed it to 20 and ran it again. Although the image improved, the difference from the dev version is still significant. I think this model's positioning is similar to the Turbo and Lightning series models, suitable for scenarios that require real-time image generation. For daily image generation without speed concerns, I prefer the dev version. However, the Schnell model is the only one among the 3 brothers that allows commercial use. So if you want to make money, this is the only choice. Now, let me talk about the specific parameters during image generation. First, switch the model back to the FP8 dev version. The following operations will use this model. In this workflow, this empty negative prompt node is different from most of the previous processes. This is because the Flux model does not read negative prompts, but the K-sampler must receive an input. Later, I will demonstrate how to use another sampler that does not require negative prompts. If you do need to use negative prompts, there is a corresponding solution. I once saw a share where someone used adapting dynamic thresholding to achieve this function. I will talk about it if there's an opportunity. The Flux guidance node, as the name suggests, is dedicated to Flux and has only one parameter. The input value will be passed to the model during inference, and the allowable value is between 0 and 100. Theoretically, when the value exceeds 1, the conditional signal in the diffusion model can be amplified, but the actual effect is not significant. Many netizens shared their practices, and I summarized them roughly as follows. When the value is near 1, the image may appear dim. When it is near 2, it is more suitable for generating artistic painting-style images. Generally, you can choose a value between 3 and 3.5 to handle different scenarios. When the value exceeds 3.5, the image details may be enhanced, but the contrast may also be high. However, it has an interesting use. When you are relatively satisfied with the generated image, you can slightly modify this value, which can fine-tune some details while keeping the overall image unchanged, just like the second seed value in the process. I increased the default 3.5 to 3.6 and then generated another image. Clicked Run. Jumped to the result, and compared the 2 images generated. Is there only a slight difference? I adjusted this value back to 3.5. Now, let's look at the parameters of the sampler node. The default value of the CFG parameter is 1, which doesn't need to be changed. When its value is less than 1 or greater than 1.5, the quality of the generated image may decrease. The sampling method is the focus of everyone's attention. For Flux, the combination of options is quite extensive. Motto 3, the author of the IP adapter plugin, tested almost all the combinations of samplers and schedulers, and generated this detailed table. He recommended 3 combinations: IPNTM plus simple, uni_PC_BH, 2 plus simple, and Euler plus beta. Based on this, I added the default Euler plus simple and my personal preference DPMPP plus SGM_uniform for an XY comparison. First, add an efficient series K-sampler node and connect it to the process just now. Then use XY plot and XY input, sampler/scheduler to select the above 5 combinations. Then, modify the seed value and CFG value in the sampler to match the previous ordinary sampler. Add a preview image node. Click Run. Speed up the process. And you'll get a large image, containing the images generated by each of the 5 sampling methods. All results are excellent. The main subjects of the images are basically consistent, with only slight differences in details. I personally prefer the result of Euler beta, so I will use this sampling method in subsequent operations. Let's continue back to this workflow. Some of you might have seen quite a few Flux workflows, some of which do not use K-sampler, but choose sampler custom. These 2 nodes actually function the same, except that the latter does not require a negative prompt, making it look more reasonable. Now let me demonstrate. Add the sampler custom advanced node. Add the noise node. This parameter is the seed value just now, change it to the same value to fix it. Add the basic guider node to connect the model and the positive prompt. Then add K-sampler select and basic scheduler nodes to select the Euler plus beta combination, keeping the iteration steps at 20. Finally, add the VAE decode and preview image nodes, and the whole process is complete. Click Run. And check the result, which is consistent with the image generated by using sampler just now. Some Flux workflows also use a node called Model Sampling Flux. This node, in addition to the size parameters, has 2 other parameters, max_shift and base_shift. According to its code, ComfyUI calculates a shift value based on these 2 parameters and the image width and height, and passes it to the Flux model. This node's function seems similar to SD3. When the value is high, the model pays more attention to the structure of the image. When the value is low, the model pays more attention to the details of the image. I added this node to the process just now. And then added a preview image node. Deleted the nodes that are no longer in use. Clicked Run. According to the ComfyUI author, using this node and keeping the default value with the dev model has the same effect as not using this node. The result shows that the generated image is exactly the same as the previous one. Interested users can also try different values. I generally leave it unchanged. Compared to the strict resolution requirements of the previous SD series models, Flux is quite flexible. According to the official introduction, it supports various resolutions. Let's give it a try. First, let's generate a horizontally long image by setting the width and height to 1920 and 208, respectively, which is roughly a 9:1 ratio. This kind of image is ideal for showcasing horizontal landscapes, like horizons or skylines. I entered a corresponding prompt and clicked Generate. The resulting image was quite good, with the sun about to set over the horizon, casting a serene and harmonious glow over the sky and sea. Vertical images are no problem either. I changed the resolution to 400 by 1600 and modified the prompt. Generating again. The resulting image was lively and interesting, showing a small cat jumping high, trying to catch a floating feather in the air. I won't demonstrate the remaining resolutions one by one, but just remember that when generating images, you don't have to stick to 1024 by 1024. Flux has an excellent ability to understand and interpret prompts. It can achieve some effects that previously required LoRa or ControlNet just by using input prompts. I'll reset the resolution back to standard and test it with some different prompts. First, let's test its ability to generate text within an image. I filled in the prompt asking it to create a logo with the text "Sheep Mia." Remember, it's best to enclose the text you want to appear in the image with quotation marks. The generated image showed a cute, innocent-looking sheep, and the text was very accurate. It's not like in the SD3 medium video, where the text "Mia Mia" turned into "Mia Mia." Flux's control over text is not limited to this. I gave it a challenging prompt, asking it to generate a presentation slide listing 3 key features of Flux in text form. Even with such a complex request, it did quite well, with the content being completely correct. The only minor issue was that the first letters of the 3 points were inconsistently capitalized. Just as SD3 can understand positional relationships in prompts, Flux is equally capable. I used a complex prompt to test its ability. Asking it to create an image with a cat holding a mouse sitting on a red chair, a dog holding a duck sitting on a blue chair, and adding a speech bubble where the cat says, "What are we even doing?" The generated image perfectly adhered to the prompt's requirements, with the positions of the animals, the colors of the chairs, and the speech bubble content all being correct. Flux also understands quite a bit about layout design, effortlessly generating content that meets the requirements for magazine covers, newspaper layouts, notices, and more. I asked it to create a newspaper themed around a modern girl, adjusting the size to match a newspaper's vertical format. The result was flawless and very impressive. Additionally, many images that previously required style transfers using LoRa or IP adapter, such as knitted styles, stickers, and game icons, can now be achieved directly through prompts in Flux. For example, by simply modifying the prompt, I could generate an icon similar to WeChat. Doesn't this generated image look very accurate? Especially those little eyes. I won't demonstrate everything in the video. When you use Flux, don't underestimate its capabilities. Although generating full-body images with the Flux model generally doesn't cause facial breakdown due to small face areas, you might still want richer facial details. No worries. Face Detailer also supports the Flux model. I'll demonstrate it now. First, switch to a full-body image prompt. Then, add the relevant Face Detailer nodes, connecting the image, model, VAE, clip, prompt, etc., and load the related model for facial recognition. Next, modify the parameters, making sure to set the CFG value to 1 and choosing the same sampling method as when generating the image, using beta. Face Detailer has many adjustable parameters. For details, you can refer to my previous videos. Here, I'll keep the other parameters as default. Finally, add an image comparison node and click Run. The effect is very clear. Face Detailer added just a tiny bit more detail. Some of you might be wondering, if the face refinement plugin works well, does that mean the face swapping plugin can also work with Flux? Absolutely correct. Reactor essentially operates on the final image, so it's not picky about the model. Moreover, it's very simple to use. Just add the Reactor node. Upload a reference image using the Load Image node. Complete the connections, and click Run. Easy as that. If you want to generate a 4K high-definition image, you can also add an upscaling process. I usually use the Ultimate SD Upscale node. Connect the appropriate inputs. Select the 4x ultra-sharp model for upscaling, and adjust the other parameters similarly to how they were set for Face Detailer, only updating the CFG and sampling method. Finally, add an image comparison node and click Run. Look at the comparison results. After upscaling, the image becomes clearer and the details richer. Now that we've covered text-to-image generation, let's try image-to-image. In Flux, image-to-image can easily achieve style transfer. This time, I'll demonstrate how to convert a real photo into an anime style. First, add a Load Image node. Select a real photo as the reference image. Add a VAE decode node, complete the connections. And for the prompt, simply write anime style. It's best not to use the beta sampling method here, as it sometimes doesn't adhere closely to the original image. I switched to simple. Keep the denoise parameter at 0.8, and click Run. The result is out. The style transfer was successful, but the similarity to the original image was low. When generating images with Flux, different seeds can produce very different results. I kept the other parameters the same and only changed the seed to generate again. And this time, the result was much better. It's not just anime style, watercolor, oil painting, and other styles can be easily transferred through image to image. So feel free to experiment yourself. In addition to full image repainting, partial repainting of specific areas is also no problem. Let me show you a simple method first. Start by loading an image of 3 cute dogs, and try to put glasses on the middle dog. Right-click on the image and select Open in Mask Editor. Then brush over the area around the dog's eyes. Next, add a V-encode for inpainting node. Pass the latent to the sampler. And write glasses in the prompt. I usually set the denoise parameter to 0.8. Click Run. And the result is great. The glasses appear successfully on the middle dog's face. In my previous video on Magic Arms, I showed how to use Segment Anything with Detailer for more precise repainting. At that time, I used some more complex plugins, which can also be used in Flux. To save time, I'll directly drag in the workflow for the Flux version. First, load an image of a girl wearing a dress. And the goal is to repaint her white dress to red. Use the Points Editor node to upload the reference image and mark the dress's position. Write red dress in the positive prompt. And click Run. The result is excellent. The girl in the red dress looks great. If you find that the repainted part doesn't fully follow your prompt, try a few more times. Because Flux uses a CFG mechanism different from previous large models, it can be somewhat unstable during repainting. By now, you should have a clearer understanding of Flux's capabilities. Overall, Flux is a large model with high image quality, strong prompt understanding, the ability to run on consumer-grade GPUs, and support for most plugins. The only concern now is the level of support from the open-source community, especially since SD3 was banned on C-Station for a long time due to licensing issues. Will developers invest time and effort in developing supporting infrastructure for Flux? For now, the outlook is very positive. The number of stars on the Flux repository is steadily increasing. XLabs.ai has continuously released multiple LoRa models based on the Flux dev model, as well as Canny ControlNet models. InstantX, the author of Instant ID, who first released the SD3 ControlNet model, has also released his Flux Canny ControlNet model. ComfyUI quickly followed suit, adapting it in the develop branch. I will bring a more detailed review later. In my view, the Flux series models are likely to become the preferred choice among open-source text-to-image large models. I will continue to monitor its performance and release more reviews and tutorials. That's all for today's video. See you next time.